Good evening, welcome. My name's Lawrence from Suburban Astro Boy. It's great that you can join us here tonight. And it's been quite a while since my last video, and part of it has been due to the weather. We've had lots of rain, and even when it hasn't been raining in Sydney, there's been scattered clouds in the sky, which made taking long exposures really difficult. It's finally cleared up this week, but I was getting worried because when I was trying to take this video and then when I was using my telescope, the mount would just not behave as it was meant to be. And it kept drifting to one side and I was getting quite worried. But I thought I'll try again tonight. I swapped from my battery powered like the telescope straight into mains, and miraculously it worked. So in this video I'm going to show how I line my telescope and how to take beautiful pictures of the Carina Nebula. Now, this video in itself is a composite of many videos that I've taken over the last couple of nights, and part of that has been trying to get my telescope mount to work, but also wrestling with the weather and the clouds, and also trying to work out how to best take this video. And so, without further ado, let's begin. Hello, so here's my telescope. It's ready to be set up. It's finally a clear night. So the first thing we need to do is align this telescope, and we'll do that through this hand controller. And what happens is that I need to point the telescope to two well-known stars, and then also maybe 3 or 4 calibration stars. And once I've done that, then the telescope mount knows where it is, and then I can start adjusting pole alignment. So let's do that. So tell it to go to 2-star alignments. Computer in the mount then is going to pick an appropriate star to go to, and in our case it is Sirius, and Sirius is one of the brightest stars in our sky. So it's roughly pointed to Sirius, and what I need to do now is look through the eyepiece and try to match where that star exactly is. So let me do that. Let me point it, look through the eyepiece. Once Sirius is aligned in the center of the camera view, we then turn our attention to the next star, which is Canopus, which is actually the second brightest star in our sky. So we grab our hand control, I'm going to select the next star, so I line that one, and there we go. Now we're going to the second star. Which is over there. So once again I'm going to grab the hand controller and I'm going to look through the finder scope and match up where the star is. With 2 stars calibrated now, it is actually possible for the mount to track stars as the Earth rotates. However, to improve the go-to approach for the mount, it is best to add some calibration stars. So we're going to do that now. Our third star, which is our first calibration star, is going to be Haida, which is a bright bluish star. The second star that we are using for calibration is Beakridge or Mimosa. It is the left brightest star of the Southern Cross. The third calibration star that we are using is Acrux, which is the bottommost brightest star of the Southern Cross. And at last, the final calibration star, which is Alpha Centauria, which is actually the closest star system to ours. The final step before we can move on to our deep sky object target for the night is to polar align the mount. This means that we need to make sure that the polar axis of the mount is accurately aligned with the southern celestial pole. This ensures that the mount rotates at the same rate as the Earth's rotation. To do this, we use the align mount function on the telescope computer, and we manually adjust 3 knobs which move the mount's latitude and azimuth to pinpoint the reference star in the center of the camera. This is to minimize the rotational star trails that exist when we do long exposures. Once this is done, we can then move on to our target, which is the Carina Nebula. This nebula is a large bright nebula which is one of the jewels of the southern hemisphere that we see here in Sydney. The first thing we need to do is focus the telescope, and when we zoom in, the aim is to get the star as small as possible. Now I'm just going to do a quick 30 seconds exposure, and this is to make sure that the nebula is where I want it to be in the frame, as well as it being in focus. That's looking pretty good. You'll notice that the stars are sharp and the nebulosity is clear and visible. The next step is to set up the auto guider. This is a separate camera which assists the mount by locking onto a single star. While it's also performing the calibration steps, I'm going to enable the cooling on the main camera. It's still a bit warm outside, so I'm going to set it to 0 degrees. This helps to lower the sensor noise. I've also enabled dithering in order to remove the sensor hot pixel noise as well. Okay, the guiding has started. We now need to wait for both the guiding RMS error and the temperature of the main camera to settle before we can begin capturing images. Okay, it looks like we have settled around an error of 0.67 arc seconds, which is great. It's time now to set up the auto run. Okay, you've noticed that it's set to 300 seconds, which is 5-minute exposures. Let's set a name for the session and let's begin imaging. We have our first image, and it's encouraging to see the amount of detail and data that we can pull from a single 5-minute exposure. Now I'll keep this out running for hopefully 2 or 3 more hours, and hopefully we'll capture enough images to stack and really bring out the detail from this nebula. Now there is one more thing that I need to mention before we get to the final image. In astronomy, there is an imaginary line called the meridian. It is a line which goes from the northern to the southern celestial poles. Once the nebula passes the meridian, the mount needs to flip to prevent the telescope from eventually hitting the base of the mount. When a meridian flip occurs, the image will also be flipped. The guiding will also need to be restarted as well, taking note to flip the calibration data. When processing your stacked images, star alignment will correct for any translational or rotational changes. I've now resumed the imaging session, with the exception of increasing the exposures now to 10 minutes each. After a total exposure of 3 hours, here is the final image of Carina Nebula. Thank you for watching, and remember to follow me on Instagram, Suburban Astro Boy, as well as Facebook.